We're ready for part 7, but what I want to do is kind of skip the stuff over the 3D, and we'll come back to that. But for part 7, I want to pick up here, so you need to find this slide, density. And this might seem kind of familiar because we did this in lab.
There it is.
Okay. So while you're finding it, somebody tell me the density of water at 4 degrees. It's a nice round number.
1.00.
1.00, what are the units then? Grams
per square
per
cubic.
either one, grams per milliliter or grams per cubic centimeter. Yes. Okay, that's the density of water at 4 degrees. It's a physical property of water. Are things denser than water? Yes. You know, you guys did density problems before. So we're going to use that property of matter, something's density, okay, grams per milliliter, how fluffy or dense it is, to basically, as a tool to get back and forth between, and if you ever want to know what you can get back and forth between, look at the units. So the units of density are mass per volume, usually grams per milliliter or grams per cubic centimeter. So those are the units we can go back and forth between, and I'm going to show you how we do this. And actually, we did this for your specific heat lab. So we're going to do a problem here, and is this less dense or more dense than water?
Less.
It is less dense. Yep. We're going to deal with methanol. Okay. Now, whenever you're faced with a problem like this in your homework or on a test, one of the first things that I do, I usually use the word unpack. I usually take that, and I'm going to do it on the next slide, but I take that and I lift it out and make it into a ratio that I can take it like that or I can flip it, however I want to do. Okay? So, what you looking for?
My purse, because my calculator's in it.
Oh, well, I got another calculator. I don't have another purse. Is it down there? No.
Right, like I'm not sleeping. I'll be right back.
Okay.
Okay.
Yeah, a purse is not a good thing to lose.
No.
No. So unpack, I would do 0.792 grams. That's approximate. There's uncertainty in that. Per exactly 1 milliliter. That's what I mean. That is the density of methanol. So notice I haven't looked at the questions yet. I kind of generally do that. Yay! And then, so the two questions we have dealing with methanol. First is, what is the mass of 242 milliliters? So basically, what number 1 looks like is we are going to go from 242 milliliters to grams using the density. That's what 1 is. So you can use stuff as a conversion factor for whatever units that stuff is. And for density, it's grams per milliliter. Or in this case, we can go back and forth between milliliters and grams. The next one is we're going to, different problem, and it says what is the volume in 50 grams of alcohol. So we're going to start with the term 50.0 grams of alcohol, and we're going to go to, I'll put question mark here, question mark milliliters, question mark grams, using, again, the density. Okay, so it's really not too bad. That's got to be a fun class. I mean, I don't know.
This one I dropped it to take this one.
You dropped it to take this one?
The guy was pretty monotone.
Oh, Aaron. Okay.
Didn't really.
With rock and roll, he's monotone.
Right?
Yeah, he was a pretty monotone guy, and he didn't really know how to run
The stuff.
notes or whatever, the stuff on the
Yeah.
projector or
Well,
whatever.
he used to be the choir director at Keokuk, and this is his first year here.
Oh,
Yeah,
well,
he seemed like he was
yeah.
pretty new at it.
welcome. I bet he'll get better.
Yeah, he's a nice guy.
Oh yeah, I mean, Mr. Evans didn't know how to run all this, and now he's getting good.
Yeah. Yeah.
It was, I don't know, just wasn't what I wanted.
Well, we're glad you're here, Aaron, I guess, to finish up that thought.
Thank you.
So this is the density of methanol. We're going to use it as a tool. There's a song like that. Okay. So the first one, the first term is going to be that 242 milliliters over 1. And what does our next term look like? The density of methanol. We want milliliters to cancel. We'll be left with grams.
0.792 grams over 1 milliliter.
Perfect. And we're done. What do you think?
Oh,
I like it. And I did bring my calculators this morning. Anybody? It's like, would I need a power calculator? Cool. Did you get 191.664? Me too. Okay, so how are we going to round that, though? 3 sig figs. I like that. 191 point.
664.
Thank you. Units will be grams, right? Because that's what we're left with. Milliliters cancel. You said 3 sig figs?
Yep.
I like that. So we're going to truncate it right here. And so what's our answer going to be? Exactly, 192 grams. So basically, based upon that density, if we want to set aside 242 milliliters of it, we'd have to weigh out 192 grams. Very good. Next one. First term is going to be the mass we want to get to volume over 1. What's the next term going to be? What grams to cancel?
1 milliliter over the 0.792.
Perfect. 1 milliliter over 0.792 grams. And how are we going to round this one?
2, 3 sig figs.
3 sig figs. Everybody buy that? Okay, so did you get 60?
63.131313131313.
Okay. Yep, sounds like we all got the same thing. So your calculator displays 63.1313, I guess repeating. You guys told me 3 sig figs, so we truncate it right here. So what's our answer going to be?
63.1 milliliters.
Does that work for everybody? Boom. Yeah. Good. Awesome sauce. Okay. So, we're going to skip the next problem for now and go on to the assignment slide. No way. Why'd I do that? Yeah, there'll be some assignments that are due for Wednesday if I'm here, or bring it to your exam if there's a test on Thursday. I'll tell you what I'll do. Regardless of whether I'm here Wednesday or not, when I get back to my office, I will go ahead and reveal these under doc sharing.
Ooh.
What the heck? I'll just go ahead and open everything up. So, but they'll still be tournament for credit. So what the heck? So let's take a look at these. These will be due, like I said, on Wednesday or Thursday. So the first one is kind of like what we just did with methanol, but it's with ethylene glycol. So they give you the density. It seems, is it more or less dense than water? More dense than water, yep. So I would unpack that puppy and feel free to flip it however you need to. The first term, what's the first term going to be in A? So it says, what is the mass in grams of 387 milliliters? That's going to be the first term for A. Over 1. And I don't want to spoil the surprise for the rest of it. Okay, so next one, what is the volume in liters? Oh, drat. So let's look at B, because I can see now it's got a little more of a twist, not too bad. Okay, so B, we are question mark liters, okay, and we starting with 3.46 kg for kilograms. I didn't leave me enough space, did I? Okay, so, whoops, sorry, capital L. So we can use density to get, oh, I see, density to get from grams to cubic centimeters, but what are we gonna have to do first with kilograms? Go to grams, exactly. So I'm just gonna put a go to grams here, exactly. Once we get to grams, then we can go ahead and use this. We can use density. I'll put the row sign there for use density to get to cubic centimeters. Okay, I'm going to put centimeters cubed here. I'm going to have to move this thing over even farther. Centimeters cubed. All right, we need to get to liters. I'm going to tell you the way I would do this is go to milliliters first. What's the relationship between centimeters cubed and milliliters? They're the same, 1 to 1, exactly. So that's how I would skin this cat. Okay? Let's take a look at the second one, a density problem. This one I had to read a few times. It's really wordy. You're like, what? And if you just kind of picture what they're talking about. They say, basically, I think of the, what was that one where the Raiders of the Lost Ark, where he takes a bag of coins and he tries to put, that's what he's trying to do here. So basically, the sand he has a density of 3.00 grams per cubic centimeter. The gold he's trying to take has a density a lot higher, right? 19. Okay. And if you read the text, the way I read it, it says the bag of both of those things have the same volume. And to me, if they have the same volume and the gold is a lot more dense, what do you think is the mass of the gold? It weighs a lot more, yeah. And I think that's exactly what they're trying to get you to do. So basically, to me, what I would do is I would say, I would take this volume and I would say, basically, find mass of 1.75 liters of both things, sand and gold. And you're right. You're going to find that the gold's a lot heavier. Okay? So that's what I would do. Okay? All right. Any questions? That's a fun one. Beware. Okay, think egg. So we're going to kind of just keep moving in the slides here. Mass percent. By definition, how do you write the word by definition? This is by definition. If somebody says they have a weight percent, they like the eggs. Okay, let's just say you guys came up with 12.5% was your shell. Okay? By definition, what that means is if you had, I'll put it up here, if you had 100 grams of egg, the whole mixture, you would have 12.5 grams of that component, shell. That's what that means. Okay? So that's a way of what I call kind of unpacking up there. So you're going to want to, right off the bat, unpack this weight percent. So instead of an egg, they basically have a sugar solution that has sucrose and water. And they have 7.2% by weight sucrose. And on the next slide, you're going to see me go ahead and unpack this, okay? But what it means is there are 7.2 grams of sucrose per 100 grams of mixture or solution. That's a physical property, and they kind of set it out top of working the problems. So then the two problems you're supposed to work, you're supposed to use that as a tool. Again, anytime you have a tool like weight percent or density, look at what the units are, and that tells you what you can use it for. So the units are grams of component, grams of sucrose per grams of solution. So here we can go back and forth between grams of solution and grams of sucrose, and that's exactly what we're doing. So the first one, how many grams of sucrose are there in 65 grams of solution? So if I was to diagram that, it would look something like this. How many grams of sucrose, so that's what I'm trying to get to, grams sucrose, are there in 65 grams of solution? 65 grams of solution. Do you see how if I put 65 grams of solution over 1, I can introduce that and get to my units of grams of sucrose? Okay, so the next one, while we're at it, changes it up a little bit. Same solution, but it says what is the mass of the solution? So I'll put arrow, question mark, grams of solution. That will contain 3.3 grams of sucrose. Okay, so that'll be my first term over 1. All right, so here we go. So here are all the different ways we can use grams. So the whole unpacking I kind of talk is in terms of a doodle kind of on the side there. So do you think this is an intensive or an extensive property? So intensive is independent of the amount of solution you would set aside to come up with this. Intensive or extensive, it does depend upon amount. How many people think it's intensive? How many people think it's extensive? I think it's intensive. Because picture it this way. Say somebody, we could use the cup in the bathtub again. Say somebody made up a sucrose solution that was 7.2% by weight. Say they have a cup of it, or let's just say they filled a whole bathtub full of it. So it's independent of the amount that you really have. It's still going to be that weight percent. Okay, so, okay. This is just kind of a note that especially working this sort of problem, you have to be, the word explicit means really clear. Okay, you have to explicitly say grams of what and grams of what, because you have 2 grams in weight percent. And I need to talk to my counterpart who teaches this class too, because I usually think of grams as potentially, even though they're grams of A over grams of solution, I usually think of them as potentially canceling each other out and it becomes unitless. But this slide says no. But my point is to make sure that you go ahead and say grams of what. So working the first one, what's the first term? Yep, 65 grams over 1. You got it. Oh, but it has to be 65 grams of solution over 1. Perfect. So what's the next term?
100 grams of solution over 7.2 grams.
Well, if I go with that, then my grams of solution won't cancel.
Okay.
Yep. 7.2 grams of sucrose. Does that make sense? Over 100 grams of solution. And then how are we going to round this?
2 sig figs.
2 sig figs. So do you guys get This? Okay. Rounded to two significant figures, 4.7 grams of sucrose. And I know, and I even hesitate to throw it out there, but I know that people are used to doing percent. You just basically take the 0.072 times the 6.5, and that's not going to get you down the road to where you need to be in this class. Okay, so use it like that. Okay, so the next one, what's the first term going to be?
3.3 grams.
Yes, 3.3 grams of sucrose over 1. And then what about the second term?
100 over 7.2.
Exactly, 100 grams of solution over 7.2 grams of sucrose. The units of grams of sucrose cancel. How do we need to round it?
2.
I'm liking it. 2 sig figs. Yep, 46. Okay, so your test this week, this would be fair game. This sort of problem? Okay. I've kind of just recently taken some of those homework problems that were a little harder, and I'm like, yeah, I don't test like that, so why should I do a homework problem like that? So, I don't know. Anyway. Okay. So let's take a look at these, and these will also be due. Okay. I'm thinking 53 I pulled. Let me see. Okay, here's what 49 looks like. Okay. So 49 kind of looks like what we were just doing. So get your wits about you. These are 3 different solutions. So there's a question about these 3, each solution. But all of them are to come up with the mass of the sucrose, given the weight percent of sucrose and the mass of solution. Okay, so they're all the same type. It's kind of nice. 53. Yeah, don't do 53. You can. What? You can if you want to.
No, I said that's fine by me.
Yeah. I'm not into it. I'm not feeling it. Okay. But go ahead and do your best with 55. So don't do 53, but 55 is still on the table. Okay? And a good strategy for working problems in any class or working any sort of homework is to, if you get stuck, you go on to the next one, right? Okay? So I think I'm just going to kind of, I think you'll do well. Okay. So we're at the end of the section. We need to go back to the first part. Okay? Back to the first part of part 7. Wrong computer. There. Cool. All right. Here we go. Ready, set, go. Okay. So what's the equality between feet and yards?
1 yard equals 3 feet.
1 yard is equal to 3 feet. Perfect. So this actually is going to bump it up just a little notch. So what if you have 1 square yard, okay, 1 square yard, here, the meter stick, but it's also yard stick. Here's 36 inches. So 1 square yard. Okay, you told me 3 feet by 3 feet. Okay, how many square feet do we have? How many people think 3? You scored. How many people think 9? Okay, very good. Well, we're going to do that using factor label. Okay, we're going to do that conversion. So yes, there are 9 feet squared, 9 square feet, 2 little cubes of feet in 1 square yard. You got it. So how this would look then is like this. Okay, so visually on the cube you saw a minute ago, you could see, or you could visualize it anyway, each side in a square yard is 3 feet. So to get the area, you take 3 feet times 3 feet, okay? And one of the things, remember, what we do in here is we kind of think of the units together. That gave us our feet squared, right? And the numbers together, 3 times 3 was 9, right? Cool. Exactly. So 1 square yard, 1 yard squared, is equal to 9 feet squared. Okay, well, here's the deal. Let's just say, and I can't remember what my builds are like, so just bear with me, but let's just say you wanted to go from, like we just did, 1 yard squared. Someone said, how many feet squared is that? Okay, and you guys already know 1 yard is equal to 3 feet. You guys know that. Well, actually, we can set it up factor label, where, like we've been doing, we put the thing we want to convert over 1 yard squared over 1. That's a square, not a cube. Okay, and then if we want to get yards to cancel, of course we're going to put 3 feet over 1 yard, right? That's great. But if we kind of do our canceling magic, only one of the, yeah, exactly. Yeah, and then if I do that first cancel, I'm left with 1 of those. So like the slide says, that's why you would need to do it 1 more time. And then that second yard will finally knock out. Okay, so this is kind of, it feels cumbersome, feels like, hey, I know that 1 yard squared is equal to 9 feet squared, but this is how you would do it factor label. Okay, so of course, the yards have canceled, because we have 2 up there and 2 down here, and we're left with feet squared, and the numbers are 3 times 3 or 9. Okay, so you could also, you guys know, we could take that second and third term and combine them together and square them. The thing is that throws us off, I'll use the word us off, is that anytime you have a quantity like this raised to a power like this, it's great, but you have to remember that that power applies to the numbers, okay, and the units in the top and the bottom. So if you expanded that, that would be what? 9 feet squared per 1 yard squared. Okay, so here's my, in so many words. Quantity raised to a power, that power has to come in through everything. Numbers and units. All right. Well, you guys told me that 1 milliliter is exactly equal to what? 1 centimeter cubed, 1 cubic centimeter, exactly. And so we're not as concerned about area like this as we are volume, okay? 1 milliliter is exactly equal to 1 centimeter cubed. So instead of, I need to switch from area to volume, basically. So let's kind of look at that. So still staying with the whole kind of yards and feet sort of thing. If I wanted to go from 1 yard cubed and wondered how many feet cubed that was, I would have to introduce 1 more term. 3 feet over 1 yard, and I could do it. That's dangerous. I was about ready to mark on there with this.
You could scratch it like you did last semester. It's still there.
Did I scratch that?
Yeah, with
That's what I
their
thought.
stylus last semester.
Yeah, dang it.
Astronomy. I
Yeah,
remember.
I thought that was
One of
me.
those days.
So what's 3 times 3 times 3? 27, exactly. So, I mean, that's kind of where we're going with this. That's exactly it. I mean, we could go ahead and, that's 27, feet cubed per 1 yard cubed. Now, I don't remember the 27 to 1 for cubic, and I don't remember the 9 to 1 for squared. I just remember the, 3 feet is equal to 1 yard. Okay. Exactly. So here I don't do much with cubing things, but 3 cubed is, like you told me, 27, right? Yeah, 3 times 3 times 3. All right. Okay. Can't remember what this did. I think we're okay. This is all just kind of saying the same thing. Or I guess another way to look at this, we talked about equalities, and you guys know 1 yard is equal to 3 feet. Is you can do, if you raise it to a power, that's okay for an equality. So actually we could go ahead and raise both sides to the power of 3, and that would be great. So there's definitely more than one way to skin this cat. So let's do a problem in 3 dimensions, a volume problem. Right. So we're not doing feet and yards, we're doing feet and yards, we're doing feet and inches. Okay? So how many inches are there in a foot? 12. Yeah, exactly right. Good deal. Okay? So what's our first term going to be? Oh, let me go ahead and diagram this real briefly. You guys told me, so basically we're going to go from 22.0 inches cubed to question mark feet cubed, and you told me correctly 1 foot is exactly equal to 12 inches. So we're probably going to have to write that 3 times on me. We are. Here we go. Okay, so the first term is I like to get in the habit of the thing we want to convert, which is the 12.0, 3 sig figs, inches cubed. Put that over 1. I'm just going to kind of stick with my builds this time. So put that over 1. What's the next term? I should just go show you what I have, because this is where students deviate. Okay? So you can see this route I went with basically the 1 inch over, 12 inches, 1 foot over 12 inches raised to the 3rd power. I would have to get a calculator and do 12 times 12 times 12, or 12 caret 3, okay, to get what that is. Okay, rounded to 3 significant figures, this is what you'll get. 0.0127, and the units will be where you want them to be, feet cubed. Does that make sense? This is where it's easy to kind of get blindsided. I prefer, actually, my favorite one is this one right here. Okay? Instead of writing 1 foot over 12 inches raised to the 3rd power, I like to write 3 terms. I like to see them all.
That's actually what I wrote.
Yeah. And it's the same thing. And you got the same answer, right?
Yep.
Yep.
1273141.
Yep. Any questions? So inches cubed have canceled, whether you go this way or this way. Okay, and we're left with units of feet raised to the 3rd power. Feet cubed. Happy feet. Well, this is a good one to kind of, I think, finish up on. This one takes it up a notch a little bit. Notice that what system is liters? metric, and what system is inches? Standard English, yep. Okay, so, so here, how many liters, question mark liters, is 25.0 inches cubed? So here's your hint. If you ever fall into this situation, what do you know between, what was the one thing with length I told you to memorize between English and metric?
2.33 centimeters? Is one
Close. 2.54, yep, centimeters is exactly equal to 1 inch. Very good. So if I use that 3 times, I can get from inches cubed to what? Centimeters cubed, woohoo! I'm loving it. And if I can get to centimeters cubed, I can get to milliliters. Yes, very good. And if I can get to milliliters,
Liters.
I get to liters. So if you ever have a situation like that, that's what I would suggest. Okay, so let's work that one. So what's the first term going to be?
25.0.
Yep, 25.0 over 1. Oh, sorry. .0 inches cubed over 1. Perfect. And then what?
2.54 centimeters over 1 times 2.54 centimeters over 1.
Yeah, exactly. Yep, this middle one right here is what I would do. This one right here is what I would put there. And then all 3 of my inches cancel and left with centimeters cubed. And then what?
Multiply that by 1 milliliter over 1 centimeters cubed.
Yep, 1 milliliter over 1 centimeter cubed. Perfect. Awesome. And then what?
And multiply that by 1 over 1,000 milliliters.
1 liter over 1,000 milliliters. Phew. Okay, let's look at the problem, see how we need to round it. Is there any uncertainty in the 25.0? Yes. How many sig figs? There are 3. Very good. 3 sig figs. Is there any uncertainty in the 2.54? No. Awesome, guys. Any uncertainty in the 1 and 1 here? Any uncertainty here? No. Okay. So 3 sig figs. So did you get 0.410?
Yep. 0.4096.
Okay, so that case the 9 rounded up to a 10. Perfect. So 3 sig figs, that's what it would have to be. It's a lot. You know, if we don't meet Wednesday, because I'm on the road, that does free up, an hour or so. I don't have time to necessarily organize for you guys to have a study session, but even if you don't have a study session or have a study session, this room will be empty. You guys could come here if you miss me. But my point was going to be you can spend some time in it. Okay, so notice I clearly marked out the second one. The second one's off the table. Let's look at the other 2 right quick. Other 3, excuse me. Good. Okay. So this is the first one. It's the 2-dimensional one, and I have to see these by written out like we've been writing them out. Okay. Just for kicks, let's see how we're doing with the metric system. On your test this week, there is going to be questions like kilometer to meters. I mean, I'm going to ask you how you.
Is there going to be like yards to kilograms?
No.
Because I think that was a homework problem, and I
Right.
took hours, and I still
Okay.
couldn't. I had the right
Sorry.
answer because of the back of the book, but I couldn't figure out how
She's
how
saying,
it
yeah,
got there.
yeah, nothing exotic like
Okay,
that.
thank God.
But, so 1 kilometer is equal to how many meters?
1,000.
Right, 1,000, yeah. So you're gonna use that there, factor label. I think you get the idea. By the way, it was blue and it was an odd number, so that means back of the book. All right, this one, 3 dimensions. Okay, basically you're supposed to go from meters cubed to 3 other different metric raised to the 3rd power. This is good to get these under your belt. The last one, let's see. This is a good one too. We've been talking about it. Density is a ratio of what to what?
Mass over volume.
Yep, mass over volume. You guys got
I
it.
want to say everything's backwards today.
And in this case, they give you the volume in, believe it or not, inches cubed. And they give you the mass in pounds. Okay? So you're basically going to go ahead and, so this one's on the table.
Grams
Yeah.
and,
So you're going to knock that out, and then,
and
yeah,
then get the density.
you're going to fix your grams to ultimately get to, sorry, not grams, fix your pounds to ultimately get to grams, and fix your cubic inches to ultimately get to centimeters cubed.
That's fine.
I think so too. All right.
Not so much over here, ma'am.
Yeah. Here, by the way, all things considered, here's my cell phone number, guys. In case you want to text me if you run into a snag, 319-750-5991.
Ooh, I'm prank calling. You got free texting, right? Unlimited, because you never know with me.
But-
And if
Okay, I'll know it's you.
everything's just coming out backwards.
So let me know if you run into any snags, and just keep checking your email, and we'll work on that email app. Okay? That's what I got. Good luck, guys.